Okay, so we're working on the sunflower. The height of a sunflower is modeled by the function h of t is this function here, where h of t is the height of the sunflower in centimeters, t days after the seed germinates. Function is only valid for the first 10 days after germination. So the domain, the realistic domain here is from 0 to 10. Okay, first of all, what are the independent and dependent variables of h? What does h of 6.14 represent? And what does h of q equal 6.414 represent? 1 minute to discuss those three questions. Go. 1 minute, discuss those three questions with the person next to you. Don't work ahead. Okay, you should have said that the independent variable, remember, what are variables first and foremost? Letters, right? They're letters. So you're not going to say a phrase that's a quantity. That's important, but first and foremost, the variable is a letter. So the independent variable is t, and that t represents the time since germination, okay, in days. The dependent variable then is, here it's actually a whole notation, right? It's not just one letter, but h of t. H of t is what we call the dependent variable, h of t, and that's the height at t days in centimeters, height of the sunflower. So h of 6.14, you should have said it's the height of the sunflower at 6.14 days after germination. Right? It's the height of the sunflower, 6.14 days after germination. What about h of q equals 6.14? That represents... All right, so now here the height is 6.14 centimeters. And so that q would be the number of days it would take to reach 6.14 centimeters, like you said. Okay? Questions on that? Okay, let's go on to B. So that was there in case you wanted to put, so we could put, remember, we can put h of 6.14 in there if we want. And nothing happens. Why not? We haven't defined the function yet. All right, so we'll put that in. We'll come back. We're going to define that function. So now we're going to define the function. And we can use any variable we want for the placeholder, for the independent variable. I want you to use A. A is an apple, okay? So you can use any variable you want. It doesn't have to be t because the problem said t. You can use any, and I want you to use A as the placeholder. So define that function h, and if you do it correctly, then up above, h of 6.14 should show a value. Remember, Control 9. Control 9 for the parentheses, for function. Control 9. So does your h of 6.14 show 40.694 centimeters? Mine could be wrong. So does yours show that? Did I put it in according to what we said? So when you get the depth that it defined properly, now h of 6.14 has meaning to GC because you've defined that function. And it tells you what? The height at 6.14 days. 40.694 centimeters. Are we good on B? Okay. Did it graph anything? Question C. It didn't graph anything. Why not? It's supposed to graph it, right? It's graphing calculator. Why didn't it graph it? Y and X are prompts to graph. All this did was define that function h. Define that function h. So we could use that function h like we saw up above, but this is not telling it to graph. So how do we graph this function now? I want you to write that command line to graph that function for the specified interval, 0 to 10 days. Graph that function. So when we graph, conventionally we put the independent variable on which axis? The x-axis, right? So looking at our definition, what's the independent variable? It's where A would be, right? And we want the independent variable to be the x-axis. And then what do we put on the y-axis? Values of the dependent variable. Values of the dependent variable. So we want y to equal value of the dependent variable for every x. So it should be h of x. But then we only want it from so yeah, so if you want less than or equal, for a graph, it's not going to change the appearance of a graph if you include the endpoints or not, because you can't really see one point at the end. But just to be consistent, on Mac, it's option less than. Usually less than or equal to. Anyone know what it is on PC? Control Shift less than. Control Shift less than. It gives you the less than or equal to. But for the appearance of the graph, including the endpoints or not doesn't change it, because you can't see one point. One point is so small you can't see it. So it's not going to change the appearance of the graph. So now it should show up. But we want a better view of this, right? So to get a better view, down here in the lower left-hand corner, you have the ability to zoom in or out of the graph as a whole or individual axes. So we certainly need to zoom out on the y-axis. So let's just zoom out a couple times on both. So what we need to do is we need to kind of zoom back in on the x-axis and continue to zoom out on the y-axis. So if you hit Option on a Mac, we want to zoom in on just the x-axis. So hold down Option. And so maybe right about there is good. And then hold down Command. And then you can zoom just on the y-axis. So we want to keep zooming out on the y-axis. So this seems like a decent view. Maybe I could zoom in on the y-axis one more time. Just whatever is going to help us to see the whole thing. Okay, this seems like a decent view. Here. Are you able to zoom in? So if you don't hold anything down, it'll just zoom in on both axes or zoom out on both axes. But if you hold down, I think, so on a PC, it's Control or what's the other one? Shift or Control allows you to isolate zooming in on one of the axes, and then on Mac it's Option and Command. Okay, Option and Command. Can you get it to look like this? Can you work at it to get it to look like this? That's what we want. That's a good view. Okay. So here's a non-graph question. Symbolically, represent the change in the sunflower's height from t equals 3 to 5.2 days. Symbolically represent the change in the sunflower's height from 3 to 5.2. That's what you worked hard in on your homework. How do we represent a change in height using function notation? Function notation. Okay, volunteer from the back. How do I do that? The change in height of the sunflower using the fact that I've defined the function. Yes, sir? Good. H of 5.2 minus H of 3. And look, because we defined that function H, GC does the calculation for us. So what does the number 19.252 mean? Change in height of the sunflower when? When the days changes from 3 to 5.2 days, right? So as the days change from 3 to 5.2 days, we're going to get a 19.25 change in height, right? And that's represented by this H of 5.2 minus H of 3. Okay? So if you touch on the graph, you can get crosshairs, and you can drag those crosshairs, and it will give you ordered pairs. So I'm going to set it, I'm going to go to 3. I think, can I get 3? Yeah, there it is. Maybe? There it is. Okay? And so then it says 3 and 12.4268. Okay? So I'm going to put in, I'm going to plot that point. Control 2, 3, and then, what was it again? Thank you, 12.4268. And my question is that point one of the points on that graph? Yes. Is that point one of the points on that graph? Yes. It is not. Why not? What's that? No, it doesn't have to do the domain. It's in the domain. The domain's from 0 to 10. That's the x-coordinate or the time. Yeah. Okay, so notice that your rule has a square root in it, right? Square root of 3. Square root of 3 is an if in the decimal that goes forever. So when I did 12.4268, what did I do? That's just an estimated value. It's a very, very, very good estimate, I should say, okay? So for practical purposes, it's essentially the same. But if we want to truly put the exact point, we highlight the exact point for x equals 3, how would we adjust that? What am I going to do instead? I want to truly get the exact point at x equals 3 that's on that graph. Someone on this side. Yeah.
3 as your x and h of 3.
Right. So instead of doing an approximation, I could do h of 3. This is important. Why? Because it means precisely the value of the dependent variable when the independent is 3. And so now we can be confident that is truly a point on that graph. Did I just add a point to the graph? No, I highlighted a point that was already there, right? That graph was already a bunch of points. I just highlighted a point that was already there. Okay, let's go on. Same thing for 5.2. And do it, get the exact point. Everyone got the 2 points plotted. Okay, so we're showing a change of time from 3 to 5 points. By showing these 2 points, it implies a change of time from 3 to 5.2 and then some corresponding change in height. Well, we want to highlight those changes. We want to add new visuals to this graph to highlight the change in time, which we could call dt, and the change in height. So we'll start with dt. So this is h. I want to highlight the change in time from 3 to 5.2 days in a visual way. So I can do that here at this point. by doing what? What should I draw from this point to show the change from 3 to 5.2 days? What could I do? Okay, so if I draw directly up vertically, does that show the change in number of days? Yeah, so up and down, that would be change in height. So I want to go which way? Left or right? To the right. So something like this. Now I have a magic pen and I can draw that. Now, but we want to do this mathematically. We want to tell GC mathematically to draw this. So this is what we need. So we got to think about that as its own little displayed graph of a set of points. So can you define in the next line for H, for part H, can you define that set of points right there? That's going to show this. It's going to, for us, it's going to be a visual of the change in time from 3 to 5.2. But on its own, it's a set of points. And so mathematically, what set of points is it? Who can do it? Go. Who can do it? Again, think of it as its own little graph, its own little set of points. What's true about y and or x for all those points? And then you need to restrict it. Anybody got it? One person's got it. Good. 2, 3, 4, 5, 6. Okay, we're getting it. What's true about all those points? That blue thing that I drew. There's the y coordinate is the same for all. If it's a horizontal line, the y coordinate stays the same. So y equals, and what does it equal? 3? H of 3. Okay, but I didn't want all the points where y is H of 3. That's why it equals H of 3. I specifically wanted from 3 to 5.2. Okay, the next one now is to, so that shows this, that's a visual representation of that change from 3 to 5.2. And so stepping back for a moment, if I'm looking at that graph, where do I look for the value of H of 3? So where do I look for the value of H of 3? Specifically. Okay, so right here. Are you looking at this point right here? Is that H of 3? Is that a representation of H of 3? Or where you would look to find that value? Some are saying yes, some are saying no. Okay, what is that? That's a correspondence point. Correspondence point, what? Is a representation of the two values taken together. It's the representation of the two values taken together. So where do we just think about looking for H of 3? No, in the graph, where the value of H of 3 in the graph, in this displayed graph. Yeah, so it's right. It's the value of the dependent variables, which we're showing on the y-axis. So something over here. So H of 3, just the value H of 3, is represented on the y-axis. That was supposed to be a straight dotted line, not dipped. Okay. So H of 3, the point is not the value of the dependent variable. The point is both taken together. It's 3 and H of 3. 3 is on the x-axis, H of 3 on the y-axis. Okay, continuing on. So we want to, now we want to show the corresponding change in height. And we want to start here. So if I'm, start here. So corresponding change in height. Like this. That show the corresponding change in height? What would I do to show the corresponding change in height? Oops. Do it. Okay, so what would it, first of all, what would it be? I've got it in red for you there in question I in red. So from here, up, down, left, or right? Okay, I'm going to go up. And this is going to show the corresponding change in height. Again, but not, we don't want to draw it on there. We want to mathematically define it. Go, do it. Mathematically write a statement that will plot just those points. Those points. Yeah, question. So if it looks like, if it ends up looking like that, straighter, you got it. Anyone got it? Who's got it?
I do.
Lots of people. Good. Okay. What's true about all those points?
All of them have an x value of 5.2.
X equals, so here all the x values are 5.2. Okay, starting from where? H of 3. And now we're restricting y values, right? Up to H of 5.2. Okay, so your next task, what I'll do is I'm gonna go ahead and show you the results of the next couple tasks visually. You can watch on the video, and then you can work on it. You can work on it at home. Okay, it's really important, so we can get to the top of it. So when you do those last 3 parts correctly, now we're gonna do a variable dt and a corresponding variation in change in height. Okay, and the point. So there's 3 things. You're gonna alter your blue segment so that n is the value of dt, and then as you vary n, the red segment will show the corresponding change in height of the sunflower correctly, and then also show the correspondence point for the final value of time and the final value of height according to n. So the last 3 elements there are to alter the blue segment so it changes with n, alter the red segment so it changes with the change in t, the blue segment, and then alter the point, correspondence point of the final value of t and the final value of height. Great exercise to work on at home because it's really testing your knowledge of function notation and graphing points. Function notation and graphing points, which you have to really know well. Questions on that? You can finish that at home, and let's do some more Top Hat questions. Today's stuff. Any questions? Okay, open up Top Hat.